Hello students, my name is Mr. Pradeep Raghunath Lande. I am from Maharashtra. I have completed my Master of Engineering from Mechanical Design domain from Pune University. I have a total 14 years of experience in teaching domain. Out of that, 4 years for JNE teaching domain and 10 years for engineering teaching domain. Today, I am going to teach a topic from circular motion to understand the basic of the circular motion and the dynamics of the circular motion. Before understanding the circular motion, we have to understand what is the circle. Suppose this is the circle and this is the center point, okay, and this is the radius of the circle. What is the fact here? The each and every point lies above this locus is the equidistance from the center of the circle. This is the center of the circle, and each and every point on this locus is the equidistance from this center, okay, and that fixed distance is called as the radius of the circle. Second thing, when suppose this is a square, this is the one square, okay, when anybody travels along this perimeter of the square, it will change the direction at this point, then at this point, and then this point at this point. So that means 4 times, okay. But for circle, it have n number of sides. It has the n number of sides. Suppose this is the particle, okay. So if you want to denote its linear velocity, you have to simply draw a tangent at that point, okay. You have to draw the tangent at this point, and this is the velocity vector v. So we have to draw tangent at each and every point. We have to draw the tangent at each and every point to locate the velocity direction at that particular point, okay. Now clear? So when the body is performing a motion along this path or in a circular path, it is called as the circular motion. Circle may be in this, like it is a vertical plane, or it is in the horizontal plane, okay. So it is a vertical motion, vertical circular motion, or maybe particle will perform in a circular motion in the horizontal plane, okay. It's clear? Now let's take what is the angular displacement. This is the circle, okay, and this is center point. This is the first position of the particle, and this is the r. We can say it's a radius vector. It's a radius vector. Then now it's the second position. The angle between these two positions is the theta, and this theta is the angular displacement. This theta is the angular displacement. So we can say the angle prescribed by the or described by the radius vector. Angle described by the radius vector, okay, in a particular time, okay. So this is called as the angular displacement. Now what is the angular velocity? The time required to describe this angle by the object, okay. There is some time required object to describe this path, okay. So here you can write d theta upon dt. That means to cover the d theta angle, particle required dt time, and this gives us the angular velocity omega. If you can relate these things to the linear velocity also, like v is equal to dx upon dt. Here the unit is radian. We have taken angle in the radian, so radian per second, and here it is a meter per second, centimeter per second, whatever unit take for the displacement, okay. It's clear? angular displacement and the angular velocity. What is the unit for angular velocity? It's a radian per second. The rate of change of angular displacement is nothing but the angular velocity. It's clear? Okay. Now take the next. We will move towards the next. What is the angular acceleration? Okay. In case of the linear velocity or 1D, we can write what is the acceleration? Is dv by dt. So in case of this angular, we are using here symbol alpha d omega by dt. Here the unit is meter per second square, but here the unit is radian per second square. Okay. Now, but there is a very big difference because this angular acceleration have the components because particle is moving in a circular path and changing its direction continuously. Okay, changing its direction continuously, and maybe the omega is constant or not constant. So we have to this check these things also. Suppose this is the circle center and the object. Okay, when particle travels along this path, its direction continuously changes. Direction of the velocity vector continuously changes. Okay, second, it has certain omega. Now when object is doing a circular motion, certain force or certain things should be there which causes to hold it in this path. ओके, इस पाथ पे उसको होल्ड करने के लिए कुछ तो होगा जिसकी वजह से वो अपना जो पाथ है वो उसे छोड़ नहीं रहा. अगर कुछ नहीं है तो क्या हो जाएगा, यहाँ पे आने के बाद जो भी कोई फोर्स है कुछ भी है जो उसे सेंटर की तरफ अट्रैक्ट कर रहा है, अगर वो वैनिश हो गया, इट विल सिंपली परफॉर्म द पैराबोलिक मोशन. इट विल सिंपली परफॉर्म द पैराबोलिक मोशन. बट अगर ये सर्कुलर पाथ को पूरा कर रहा है, दैट मीन्स इट इज समथिंग विच इज होल्डिंग इट on a circular path. Okay, so first of all, this on circular path, let's see this. Suppose this is a velocity vector, this is the object. Okay, this velocity have the relationship with angular velocity v is equal to r omega. V is equal to r omega. If you take the derivative with respect to time, dv by dt is equal to r d omega by dt. R is the radius and d omega by dt is the alpha. So dv by dt, you can say it's a tangential acceleration because the velocity is tangential to the path. Velocity, linear velocity is the vector which is a tangential to the circular path. Okay, so the acceleration along this path we can see it's a tangential acceleration, at r into alpha. Okay, now this alpha is totally depend upon the changing speed. We have to remember this. If speed is zero, that means omega is 0, then you can write at is equal to 0. Now when the particle performs the circular motion, I already explained, something is holding it or attracting it towards the center, just like we are saying the earth. This is the earth and the moon is moving around the earth. Okay, moon is performing near about a circular motion. This is the line of force from center to center, or we know this force is the gravitation. Okay, we already know this. Okay, so force, what is the force? Mass into acceleration. So body has some mass, so definitely in this direction if force is there, acceleration should be there, and this line is perpendicular to this tangential line, so it's normal to this tangential. We can say the acceleration is an, or normal acceleration. We can say normal acceleration, and formula is v square by r, v square by r. So here we can write v is equal to r omega, v is equal to r omega. We can put a is equal to r square omega square divided by r. Okay, then we get omega square. It's a normal acceleration. Okay, and the total acceleration we can write for body at square plus an square, at square plus an square. So next takes relative angular velocity. So what is the relative angular velocity? It's just like a relative velocity. In case of linear motion, we are writing relative velocity. Suppose there are two bodies, there are two bodies, va, vb, having a velocity va and vb, and the distance between them is the r. This angle must be 90°. We have to take care the line joining the tail of this both vector, okay, is perpendicular to the direction of velocity. So we can write omega ab, that means omega of b with respect to a is equal to vab upon r. Now the both object have the direction in same. We can write vb minus va upon r. Similarly, if both have opposite direction, is va vb, we can write omega ab is equal to vb plus va upon r. Okay, consider these two cases. Now we have to look for third case where the velocity having some angle, okay. Suppose this is the vector va and this is the vector vb. va vb having angle theta 1, having angle theta 2. So we have to find out perpendicular component of this velocity. How we can write? va sin theta 1, vb sin theta 2, and we can write then omega ab vb sin theta 2 minus a sin theta 1 upon r. Okay, just you have to take the sine component of the velocity. Stick concept UCM, okay, uniform circular motion. UCM non UCM. What is UCM? Where omega is constant. Omega is constant. So when omega is constant, d omega by dt is equal to 0. That means alpha is equal to 0. Okay. But an, which is not depend upon the velocity or speed, is not equal to the 0. So we have to calculate the an. We have to calculate the an. Then for non-UCM, omega is not constant. Omega is not constant. So d omega by dt is there. Also this an r omega square is also there, and total acceleration at square plus an square also is there. Okay, we have to calculate the total acceleration for this case. Here also omega is not constant, but alpha may be constant. Alpha may be constant, or alpha may be variable. Alpha may be variable means acceleration is constant, or alpha acceleration may not be the constant. Okay, so simply we have to use the equation of motion by replacing linear velocity its parameter by the angular velocity parameter in case of the alpha is constant. So in case of linear, suppose take example, we are writing v square is equal to u square plus twice of s. So here we can write final angular velocity is equal to initial angular velocity square twice of a alpha s theta. Okay, just we have to replace the linear velocities thing with the angular velocities thing. Here v suppose is equal to u plus at square, so we can write final angular velocity, initial angular velocity alpha t square. Okay, but in case of non-uni, if alpha is sorry if alpha is variable, they will give a certain relationship, like alpha having a relationship with time like 5t square, 5t or 2t. Then you have to calculate the value of alpha at that instant, and then you have to use that value. Okay, then you have to use that value. Okay, so see next, centripetal force and centrifugal force. Okay, when body travels in the circular path, we already discussed, something is hold that body in on that particular path. Something holds that on particular path. So this is a body traveling with tangential acceleration at and normal acceleration an, having the mass. Suppose we multiply this angular acceleration by mass to m into v square by r, and this is nothing but actually a force. Okay, you can say kg meter square per second square upon meter gives you kg meter per second square, thing but the Newton. Okay, so it's a centripetal force which is responsible to hold the body on a circular track. Okay, which is responsible to hold the body on a circular track. You can calculate by this formula mv square divided by r, or you can replace v by r omega. You will get formula mr omega square. Okay, now moving towards the concept of the centrifugal force. Actually, the centrifugal force is the pseudo force which exists only in the non-inertial frame of reference. Okay, non-inertial frame of reference. Okay, this is the circle. This is, suppose your body traveling with some acceleration and your observer is sitting on that body. Okay, then and then only you can say this centrifugal force is applicable. Okay, and we are writing definition. Centrifugal force and centripetal force are equal and opposite in direction. Okay, but when this exists, when the frame observer itself is in non-inertial frame of reference, magnitude, okay, same mr omega square. So to remember, magnitude is the same mr omega square. Okay, now simply this is the case of pendulum. This is the pendulum and it moving doing a to and fro motion. Okay, with omega. So and having mass m. So we can say this string have the tension T, having the tension, and weight acting downward is the mg. Okay, now the centripetal force is the force which responsible to keep a body in a circular track. So we can write T minus mg. आपको क्या है, इक्वेशन बनाना आना चाहिए. T minus mg mv square upon r. The total summation of the forces is equal to the mass into acceleration. Simple logic is there. T is always act away from the body. Okay, away from the body. So T minus mg mv square upon r. Okay, this is the equation for pendulum. Now moving towards the conical pendulum.